Welcome to an example in which we have this pole. Let's see, a pole stands 75 feet tall. An angle theta is formed when wires of various lengths of x feet, this is a wire right here, okay, are attached from the ground to the top of the pole as shown in the figure. So from the ground up to the top of the pole, wires to hold the pole steady, I guess, some kind of engineering thing. Find the rate of change of the angle d theta dx when the wire of 231 feet is attached. Okay, so here's the trick on this one. So we have to do a certain order of steps. So step number one, find an equation with x and theta. Some kind of connection. Well, you can see this is a right triangle, right? Sorry, my drawing is not so great. Okay, little right triangle there, trying to now remember your trigonometry stuff, this side is opposite from the angle theta. This side where the wire is hypotenuse. That makes this side adjacent. Remember that whole thing? And do you remember SOHCAHTOA? What we use in right triangle trigonometry. So whenever we have a right angle in a situation, we can use SOHCAHTOA because hypotenuse is the side opposite the right angle. Okay, so now how do I know if I want this is sine, this is cosine, this is tangent? I didn't draw that zero there. Okay, how do I know if I want sine or cosine or tangent? Well, look at the sides you have and want. I have 75. I want that x. I don't know anything about the adjacent. There's not a number. It's not an x. I don't care about it at all. I only care about opposite and hypotenuse. So which trig relationship involves opposite and hypotenuse? Sine, opposite, hypotenuse, right? So I'm going to go, oh, okay. So sine of the angle theta, right? We take sine cosine tangent of an angle is going to be opposite, which is 75 over the hypotenuse, which is x. So notice that's opposite over hypotenuse, right? OH, opposite over hypotenuse. The opposite is 75, hypotenuse is x. Okay, so there it is. That's the first step. That's just the first step, unfortunately. Um, step two, I don't know where to do step two, bring down here. Step two, get theta alone. So I'm going to bring down this relationship. Sine of theta equals 75 over x. And I want to get rid of this sign so that theta can be alone. How do you do it? Do you divide by sign? No, I hope you know by now you don't divide by sign because this is not multiplication. That's the really common mistake a lot of students make. Whenever you have theta and x, whatever, after a trig function, sine, cosine, tangent, or any function, f of theta, f of x, g of x, right? Anytime you have something after a function, sine, cosine, tangent, f, g, h, whatever, that's never multiplication. That's plug-in. That doesn't mean sine times theta, it means sine of theta, like f of x. Meaning the theta is plugged into the sine toaster. That's the analogy I always use, right? Like the bread plugged in. So in other words, it's not times. So therefore we can't divide. Well, then what do we do? How do we get rid of that sign? We do the opposite of sine, which is sine inverse. Whatever we do to one side, you have no choice but to do the same thing to the other. These cancel, and theta is sine inverse. Now, let me make life a little bit easier for us. I'm going to make this 75 x to the minus 1. That was just because I don't want it to be a fraction. See how this is a fraction and we hate fractions. So then I change it to not be a fraction. So now it's not a fraction, but it's still the same thing, right? X to the minus 1 is the same thing as putting x on the bottom. So there it is, not a fraction. It's going to be easier to deal with going forward. So we got theta alone, that's step two. And now for the big, the bad, step three, find theta prime. That's where we're going, right? Theta prime. So we got, okay, got to take the derivative. So here we go. So the derivative, scoot it this way a little bit. So the derivative, theta prime equals. Now, how do we do the derivative of sine inverse? Do you remember? Let me put it. somewhere. It's kind of, put it right over here. Um, Sine inverse of x, the derivative is, for sine inverse, 1 over the square root of 1 minus x squared. So that's how we do that. Okay, so coming on down here, I'm going to use that rule, and I'm going to go, okay, square root down here. Here we go. 1 over 1 minus. Now, it's not just x squared, is it? Because, whenever we have a math or science formula, whatever is x, that goes right there, right? It's just telling you plug it in right there. What do we have inside? We have this. So that's going to be the whole 75 x to the minus 1, and then that is squared. Let me extend this a little. We good there. Do you see that? We're not done yet. We have a little bit more to do. But is that step okay so far? Right? I just followed this rule, except it was not sine inverse of x, it was sine inverse of 75x to the minus 1. So it's 1 over the square root of 1 minus 75x to the minus 1 squared. But why aren't we done? Because of the chain rule. You're getting used to the chain rule, right? If the inside, this inside right here, or let's do this one. Back that up. I don't want that fraction. I want this one. So if the inside is not a simple x, then we must do the chain rule, which means another length, which means times the derivative of that. So how do you do that? We'll bring this down, minus 75, subtract 1 from the power, x to the minus 2. Chain rule. Again, if the inside of any function is not a simple x, then when you do the derivative of the outside, then you got to multiply by the derivative of the inside. That's the chain rule. All right, let's clean this up a little bit. So this is theta prime equals 1 over the square root of 1 minus 75x to the minus 1 squared. And then this guy, this minus 75, this will go up here on the top, right? Because over 1 multiply. So I'm just going to stick it on the top. So it's going to be minus 75x to the minus 2. So there's the derivative. Now, last step. They're going to say, okay, you got the derivative. You got all that work done. Now plug 231 into that derivative. So now I'll just plug in 231 there, 231 there for x. Hit the buttons on your Desmos calculator, and you'll get this. It's radians per foot. That's how the angle's changing as x changes. And so there we go.